This is an ASD1 question on critical path analysis. The table above shows the activities required for the completion of a building project. For each activity, the table shows the time taken in days, that's it in the second column here, and the immediately preceding activities in the last column of the table here. Each activity requires one worker. The project is to be completed in the shortest possible time. Figure 2 shows a partially completed activity network, that's over here, used to model the project. The activities are represented by the arcs, and a number in brackets on each arc is the time taken in days to complete the corresponding activity. Part A, add the missing activities and necessary dummies to diagram 1 in the answer book. Okay, so this is diagram 1 that you would find in the answer booklet. We're going to go through this table here and use the activity network we've got up here to fill in any missing arcs, including any dummy arcs, and then we'll add them to our diagram here. So A, B and C aren't preceded by anything. Okay, so that's fine. Let's tick those off. D is preceded by A and it's got a length of 14. So this is only going to be temporary. So D 14, and then we have E is also preceded by A, that's 10. Okay, so just put this on. I might need to move these around in a moment. And then we've got activity F, so let's tick these off. Activity F, which is preceded by B, C and E. So here's activity F, it's preceded by B. Okay, so that's there already, that's fine. It needs to be preceded by C. Okay, so we need to have an arc here. Now it's preceded by C, but this needs to be a dummy activity because there's no weight on this, it's just showing precedence. So dotted line here for my dummy, so I've got it preceded by C, and then it needs to be preceded by E. So this E that I've drawn here needs to be going into this point, so let's just redo that and put E here, and the length of that was 10 again. Okay, so that can be ticked off. Then we move on to G. G has got a length of 7 and needs to be preceded by C. Okay, so let's put that on. So it's going to be something like this. So G and a length of 7. Then we go to H. So H is here. It needs to be preceded by D, F and G. Right, okay, so it's already preceded by F. D, okay, so D now needs to be put over here. So we'll just rub that out and put that in. So now H is preceded by D, and that was the one that had a length of 14. And it also needs to be preceded by G. So G we need to move up to there. Shouldn't have any arcs just floating around. Okay, so let's put G here. Let's start to put these in brackets. Makes more sense. So G was length 7, D is 14, and E is of length 10. So we've now got H being preceded by D, F and G. Great, so we can tick that one off. And now we move on to I, which needs to be preceded by H, which it is, and its length is 7, duration is 7, that's fine. And then we've got this activity J, J's not on here yet, and it needs to be preceded by H. So we've got J here, which is going to be preceded by H, and this has a length 9. But we need to link J and I together. So this is an activity, this is just showing right a dummy activity so that we get to the endpoint at the same time. So that can be ticked off. And what I'm going to do now is to take the extra arcs and the dummy arcs that I've added to this diagram and add it to this diagram here. Okay, with that done, we can do a forward pass and do the early event times. Remember, that's the latest time at which I can get to a certain point. So we always start with zeros in our start box here, our start times. Right, okay, how about getting to A? Well, it doesn't rely on anything else, so the latest time I can get to this point here is 5, so we're doing a forward pass, only the top boxes. Here, okay, there are no other routes to get to C, so it's going to just be 4. However, when we get to B, so you've got 8 to get to here, but the earliest we can get there is going to be 5 plus 10, 15. Yeah, it's going to be the longest time. That'll be the earliest we can get to this point. Okay, let's continue. So to get to here, right, what are the times? So 5 plus 14, I'll write them down, 19. I want to pick the largest of them. So we've got to here, that's 15 plus 3, that gives 18. Or this route here, 4 plus 7 is 11. So I have to pick the largest of those. So it's going to be 19, that's the earliest at which we can get to that point. Then continuing, we're going to continue from 19, so it's only going to be the 19 plus 5, 24. Then to get to J, 24 plus 9, 33. Now to get to this final box, it's either going to be the 33 that we have here, because this dummy has no weight to it, or it's going to be the 24 plus 7, which is 31. Remember, we take the highest of those, so it's going to be 33. So we've completed our forward pass. We now work on a reverse pass. Remember that the late event time here needs to be the same as the early event time, so this also needs to be 33. So working backwards, no weight on this dummy here, so this is also 33. Now as we work backwards, we take the lowest times, so here 33 minus 7, 26, or here 33 minus 9, and that gives 24. We take the lowest of those times, so it's going to be 24. We continue to work backwards in reverse, so 24 minus 5, there are no other routes, so it's just going to be the 24 minus 5, 19. And before we continue, just realise I should really have some arrows on these arcs here to show that I'm working forward, because now I'm going to be working backwards. Now, okay, 19 minus 3, so we've got 16. That may change if I get a lower value going this way. So this could be 16 because this dummy has no weight here. And 19 minus 7, 12, so we take the lowest one, 12. So that goes in there. Now I should also put direction arrows on my dummies as well. Now with the 16, if we work backwards, 16 minus 0 is still 16, so 12 is still the lower value, and then we can work our way back to this point here. So we have 19 minus 14, which will give us 5, or we will have 16 minus 10, which is 6. We take the lower value, which is 5, and then that completes it, because we're going to be back to 0, 0 at the start node. Okay, so that completes our diagram. Part C, we need to state the critical activities. So they're going to be activities where the numbers are the same either side of the activity. So let's just highlight those. So I've got 2 zeros, 2 5s. So you're just finding the boxes where the top and the bottom number are the same. Okay, and then the activities between those are the critical activities. So it looks like A is between 2, so is D, H, I, and J. So we'll just state them. So the critical activities are A, D, H, I, and J. At the beginning of the project, it is decided that activity G is no longer required. Part D, explain what effect, if any, this will have on first part D, part I, part 1, the shortest completion time of the project if activity G is no longer required. Now this will have no effect because it's not a critical activity, so no effect on the shortest completion time as G is not a critical activities. It's only critical activities that have effects on the completion time, the shortest completion time. And then part I, or the second part of part D, the timing of the remaining activities. Now if we scrub out activity G and see what effect that's going to have. Now it's going to have an effect on the late event time at the end of activity C, because before we had a choice of 16 or 19 minus 7, which is 12. So actually what we'd have here in this box would be 16. So that changes the late event time for activity C. So activity C can finish as late as 16, and its length is 4, so it can start as late as 12. So we'll write that in words. So the only activity affected is activity C, as we've just said, which can finish as late as day 16. Because the length of activity C is 4, it does mean that it can start as late as day 12.